So, can you tell me your name and the company that you're representing?
So I'm Evan Lucas, and I'm one of the co-founders of Panverse Robotics. And what we are working on right now is a platform for 3D Gaussian splatting that we call Portality. And what you can do is you can take a bunch of footage, either videos or images of things, you can upload them, and it makes a 3D representation of it that's photorealistic.
So, you said you're using Gaussian splattering. What is that?
Yeah, that's a good question. So Gaussian splatting is where it's a rasterization technique where you're going to represent the scene as a point cloud, except instead of points, you're going to use clouds, like Gaussian distributions. So they have a high strength near the center and they taper off just like a bell curve, but in 3D. So you can think of them as like little oblong balls of color. And so you have a scene that's composed of all these little blobs of color. And then the splatting part is how you rasterize them. So you think about your image plane and you have this big cloud of different colored points and you throw them against your image plane and they splat, and that makes the scene. So all the light blobs, all the colored blobs that are closest to your image plane hit this image plane and they make a picture. And that's why you call it Gaussian splatting, because you have this cloud of these color distributions and they splat onto your image plane.
What do you see this being used for? Like, what's the usage?
Well, the first thing that we'd like to use it for is to allow people, for any reason, to make 3D representations of things and share them with their friends or family or customers. So we think there would be uses for this in like the maker space. So makers who make really cool things, maybe they make some bespoke furniture or they 3D print something really cool and they want to share it with somebody and they want to share the full 3D nature of it. This would be a way for them to share that whole 3D model, and their friends or their potential customers can spin it around and look at it from different angles. We think also this could be really good for selling houses. So instead of having to drive out to a house to look at it, you could load up your Gaussian splat of a house and spin it around and see what it looks like in 3D from your computer or your smartphone.
So, it works with any size objects?
Yeah, absolutely. We can do it with house size objects like we worked on today. We could do it on a desk. We could do it on anything in between. I haven't seen it done with microscopy yet, but I think that could be a really fun thing to try at some point. Absolutely.
What does the user have to input in order to make this system work?
Yeah, okay. So what the user's gonna do is they're going to take a bunch of pictures of something or they're gonna take a video of it. And generally, if it's like an object that you wanna look at from all around, you're gonna take pictures from all around it from multiple angles. And maybe if it's just a scene that you only wanna look at from one direction, that would be appropriate to just take pictures and videos from just that one direction you wanna look at it in. And then what our software does, first it's going to take all those pictures or the pictures that it samples out of the video, and it's going to reconstruct where the camera was when it took that photo. And so we're gonna have a bunch of camera pose estimations, that's what we call them, where we're assuming we're trying to figure out the camera is here or the camera is here. And then we're going to try to construct the Gaussian cloud based on those images. So we're gonna say, well, if it looks like this from this angle and it looks like this from this angle, one potential solution for the 3D model could be to have a little blob of color here and a blob of color here and a blob of color here. And that's how we initialize the scene, is by estimating where all those points are. We put the different Gaussians in there and we try reshaping the Gaussians and adding Gaussians and tweaking them to try to get it to match the images as best as possible.
You've essentially entered the realm of the AI startup boom, I guess you could say, right? Is that a thing? Or is this AI or is this something else? Or where do you put this at?
Yeah, that's a great question. We do consider ourselves to be an AI company. Yes, we are part of this AI boom right now. The process of trying to learn what the Gaussian scene is in order to photorealistically represent whatever object or scene or thing that you're trying to recreate in 3D space. The process of that is a deep learning process. So the cool thing and the thing that enabled 3D Gaussian splatting to become a thing when it got published last year is having a differentiable rendering process. And so that rasterization that I talked about earlier, where you have your Gaussian cloud and it splats onto your image plane, that process is differentiable, which lets us train the model through backpropagation. So we're able to do typical machine learning methods and run this on a GPU and optimize our 3D cloud by nature of it being a differentiable process.
So how is something like this different from, say, like Polycam? It's an app like on your phone that you can do this kind of stuff with.
That's a really good question. Polycam is very similar. They're using something called photogrammetry. And in photogrammetry, they're actually trying to make a 3D model. And what happens when you do that is that it's not able to capture a lot of the same visual detail, because it's going to make assumptions about what that underlying 3D structure looks like first, and then put the image onto that, rather than trying to directly represent the scene. So in our method, which we're using, which is 3D Gaussian splatting, we're actually trying to represent the light field. So Gaussian splatting belongs to a bigger field that's called neural radiance fields, where you try to make a 3D scene representation of what light is emanating from things. So as the sun comes and hits my face right now, which is why I'm squinting, that's then reflecting off, and you have light radiating from my face. And so if you were going to make a Gaussian splat of me right now, you would be collecting the light and trying to model the light that is radiating from every part of me and the scene around us, etc. And so our method, we're trying to model what that light field looks like specifically, rather than trying to directly model what the underlying 3D structure is and then put an image onto it, which is essentially how photogrammetry works in about a sentence.
So, okay, so photogrammetry depends on light, or your method depends on light, or yes?
Yes, they do both depend on light. No, that's totally true. Photogrammetry, though, is trying to estimate like an underlying physical structure, and we are trying to estimate visually what's going on. So you could think of it as optimizing first for what is the physical structure versus optimizing for what is the camera actually seeing, and trying to reconstruct what the camera sees. Because the camera doesn't really see me, the camera sees the light that reflects off and radiates from me.
Gotcha. And does that mean that the method you have is susceptible to changing light sources?
Yes, and there are papers that people have published about how to possibly correct that. So that is something that we would like to look at in the future, but it is an active research topic of how to handle light sources that change, things like that.
The idea to form Panverse Robotics and to put a software like this together came from where?
We met on the internet. So we all belong to an internet community that started popping up during COVID, when COVID was at its peak, and we became friends. We talked for well over a year, and we flirted with the idea of making a startup together, and eventually decided, hey, let's do it for real. And so last summer, we finally filed our LLC paperwork, and we wanted to do robotics, and decided the first step towards doing robotics right now would be to try to work on some neural radiance fields methods, which were very popular at the time. And we thought there was a good opportunity in the market for a consumer platform for them. We also saw that as a stepping stone into more robotics-y applications. So you can use a neural radiance field representation of a 3D space to do things like path planning. So like flying my drone earlier, we could try to take the neural radiance field or the Gaussian splatting scene and use that to design like paths of where the robot would fly through a scene for different applications. And then last fall, we were seeing online that this 3D Gaussian splatting paper, which came out last year also, was starting to really pick up traction. And so we were like, you know what, we should grab onto this. This is really hot. And that's how we pivoted to doing 3D Gaussian splatting.
Can people use this software right now?
People will be able to use this software by the time this video is live. So right now, our website is only open to alpha testers that we have personally vetted. But by the time this video goes live, we are going to have it open to anybody. And you can access it at portality.ai.
And potentially looking to monetize, is there a plan for that or no? Or
yeah, absolutely. So what we'd like to do is we'd like to do this as a subscription service. So if you pay a monthly fee, you can go and use our platform. You can make as many things as are reasonable within some limit. We have to set that. And then you can share your different 3D Gaussian splats with your friends, your customers, etc.
So we have our model done now.
Yeah.
And how long did this take to render? Like, how long did it take to assemble this?
It took about 45 minutes to an hour. I don't know the exact amount of time. Most of that time is taking all of the images that we took and trying to register them within the image space. So trying to figure out where each image was taken from in 3D space around your object. And then a smaller amount of time was spent processing it into this model that you can see here.
One of the things that I noticed when we were looking at it beforehand, or kind of based on like what you'd said, is there actually texture in here, or is it pseudo texture because it's like little blots of light?
Yeah, so it's not actually like a texture. If you look like, especially like here at the ground, you can see all these little needle-like artifacts, and those are the Gaussians themselves that we are looking at. And so what appears to be texture is actually the combination of lots of little Gaussians next to each other that make it look like a texture. You can also see the opposite of the needle-like effects when you zoom out, and you see all of the big blobby textures out here, or not textures, the big blobby Gaussians. And so like this out here, you can see it's a big oblong space. That is one big Gaussian there. This little needle is another Gaussian. And so it's trying to represent what it sees in the image by combining all of these Gaussians. So it's not actually a real texture, but it kind of approximates the texture by...
So it's like the lines on my solar panels are actually probably oblong Gaussians, right?
Yeah, it's probably like a bunch of little Gaussians together. So like if we zoom in real close to it, yeah, so you can see the lines are actually, yeah, lots of little Gaussians stacked up next to each other. So you can see like some places where
it gets a little rough.
Yeah, it gets a little rough. We didn't have enough footage covering that one. But like here, you can see, yeah, lots of little Gaussians stacked up to make those lines on your solar panels.
Yeah, and zoom out one more time. Gaussian look, it kind of has the almost ethereal kind of feel to it. It's like the sky actually has a volumetric feel to it now, and that's what makes it feel. Is that why you guys went with the name, that name Portality, or?
Yeah, so we were trying to think about what this felt like, and to us that kind of felt like a portal, like you're peering through a portal at a place that you've captured in time and space.
Yeah.
And so we started thinking about imagery of portals, and so obviously the most obvious example is the Portal video game.
Oh yeah, and it does feel like that. The edges of the portal look like that, yeah.
Yeah, and so that's where our loading screen came from, was the inspiration of the portals with the portal gun in Portal 1 and 2. But we also thought about the imagery of a portal, which is like the traditional symbol of like a hole in the wall or a hole like going into a building. And that's usually an arch, and so that's where our logo came from, was the portal of an arch with stairs going up to it.
Cool.
And then of course, yeah, Portality comes from portal. Yeah, it's kind of cool the different kind of artifacts that you get, because if you use like a neural radiance field approach, like NERF, not specifically Gaussian splatting, you get different types of artifacts. So there, they typically show up more as like wispy clouds that show up around your objects. And so here the artifacts, when you don't have good coverage, are these either blobs or needle-like objects. And we're working on some methods to be able to remove those. So either we could just crop out everything at a distance, or one thing that we've worked on is trying to do like a cropping, or a segmentation-based approach, where we can pull out like just the object of interest, and it would look like your house was just floating in space. And I can show you what that kind of looks like if you want. We have a demo up of a shoe. Okay. Yeah. So this shoe demo that we have here, this has been a segmented model, and so everything under the shoe was segmented away. So you can see there's no actual images of the bottom of the shoe, and it's just all blobby Gaussians. But yeah, this has been segmented so that you only have the shoe in the scene. I should note that we did not prepare this data set. This is one that some other people have prepared, but it's
Not your shoe.
not my shoe. No, I don't have any shoes this cool.
So can you go back to the house one?
Yeah, of course.
What do you think someone would do with this? Like I have a couple ideas what I would do. But like if I had this model in my house, besides for like, I know we talked about real estate, but what else do you think someone could do with this? Or do you envision seeing people using this for?
Yeah, so we think that different types of online content creators, like people who are makers, who make really intricate 3D printed parts, or maybe people who make furniture, or maybe people who make other things that they craft, and they want to show off their bespoke creations that only one might exist of in the world. We think that this would be a good tool for showing off those types of things, because it lets you spin it around and look at the different aspects of it.
Sure. Yeah, I actually, I thought, I'm inviting someone that's never been over to my house before, over to my house, and I was literally thinking about sending them this link and saying like, oh, just so you know, because I live down a jank driveway that you might think is not really it, and so I figured, yeah, I could just send them a model of my house.
Yeah, that'd be really cool. Since all of our photos were focus taking, looking at the house, we didn't really get like what the surrounding of the house looks like, but we could pan the camera over and actually if you send them that, they might get scared.
I live in a Van Gogh painting.